Welcome to our lesson on calculating the work required to pump water out of a tank. Let's solve this step by step using calculus. Let's start by drawing our tank. We'll consider a cylindrical tank with radius r and height h. The tank is filled with water, which has a density of 62.4 pounds per cubic foot. The outlet where we'll pump the water is at the top of the tank. To solve this problem, we'll use a differential approach. Let's consider a thin horizontal disk of water at depth y from the top. This disk has a thickness of dy and the same radius r as the tank. The volume of this differential disk is pi r squared dy. Now, let's calculate the weight of this differential disk. The weight equals density times volume. So, dw equals 62.4 times pi r squared dy. To find the work required to pump this disk of water, we need to multiply its weight by the distance it needs to be lifted. The distance from depth y to the outlet is h minus y. So the differential work due equals dw times h minus y. To find the total work, we need to integrate this expression from y equals 0 at the top to y equals h at the bottom of the tank. Our integral becomes u equals the integral from 0 to h of 62.4 pi r squared times h minus y dy. Let's solve this integral. First, we can factor out the constants. The antiderivative of h minus y is pi minus y squared over 2. Evaluating from 0 to h gives us 62.4 pi r squared times h squared over 2 foot-pounds. This final expression gives us the work required to pump all the water out of the tank. The work depends on the density of the fluid, the radius of the tank squared, and the height of the tank squared. If we know the specific dimensions of our tank, we can plug them into this formula to get the exact work required.